Good morning. This is our second class for today. Uh, C++ and data structure. It will be our lecture 3. The course code is CSB 1212 and CSB 1215, which is the lab. So I'm combining both the classes in this slide. Today's class content will be Block 2, Unit 8, which is Understanding the Template and Exception Handling. And Block 3 is will be in the Introduction to Data Structure, which comes with Unit 9 and Unit 10. We'll try to finish the 3 unit from Block 1, or Block 2, 1 unit, and Block 3, 2 units. So we'll try to complete as much as possible. So our objective for the class is to understand and apply advanced C++ programming concept, including template, to develop generic and reusable code components, implement and manage exception handling mechanism in C++ program to ensure robustness and error control in software application. Explain and analyze fundamental concept of data structure, including abstract data types (ADT) and their role in efficient problem solving. Next will be demonstrate the use of the throw statement for raising exceptions, evaluates the efficiency of data structure using time and space complexity analysis and apply appropriate big O notation, understand to apply multiple catch blocks to handle different types of exception, and last but not least, compare and select suitable data structure arrays versus linked lists based on performance requirement and application scenarios. So moving to our unit 8, let's first understand what is template. Templates in C++ enable generic programming, allowing functions and classes to operate with any data type without rewriting codes. Okay, they improve code reusability, type safety, and maintainability. The function of this template is a function template defines a blueprint for a function using a generic type. Syntax will be template type name with the code and T add T A T B means T for type name, okay, and return A plus B semicolon and close bracket. This is how the template syntax will be. Next is a template example. It will be better if we explain the example with example. So as we have seen the syntax of the template, this is how the example will be. For better understanding, we have used one example here. Include in C++, we always say hash include IO string. Key points is using namespace and std semicolon, right? Is case sensitive, so you have to do that. And here key point of the type name or class. Can be used interchangeably. So compiler generate function based on type use. Support multiple template parameter. Here we can see template type name T maximum, TATB, return A greater than B. Or here question mark will be there if A is to B semicolon. So in main C out is the symbol greater than maximum 10, 20. So among this number we have to display which is maximum. So then end line ENL. So this will be end line. So int. This is int. and C out. Another one is there 5.5 comma 3.2. That's double then and line. This is double. Double means like there's a decimal here, so it will be double. Return 0. So the output from here type T type name. This is in, this is double. So C out. What we have to if A is greater than B, return, right? Maximum. Which one is maximum from first number? 20 is maximum, and here in second number 5.5. Next is our class template. Let us understand what is class template. Class template allow creation of generic classes. Generic classes. This the advantage. Here we have put some syntax of the class template where it will look like template class T. T is template, so we have written here class T. Class box. Then under box we have put the value T value. No? And what is it? Public or private? It's a public. We have taken here public. So void set value TV value equal to V. Then T get value return value. So advantages of class template will be avoid code duplication and works with any data type, promotes abstraction. Okay. Example, int main example, you see int main box int and int box dot set value as 100 so box string and then str box dot set value. What will be the value of the str? Hello within code. Then C out int box dot get value and L. Then C out str box dot get value and L. See, this is how the example will look like for the class template. So here one is string, one is int value. So here no duplication of the code is generated, works with any data type and promotes abstraction. Next is our exception handling. Exception handling in C++ is the exception that manage runtime error. Runtime error gracefully without crashing the program. Without crashing the program, it will manage the runtime error. So the key commands try, throw, and catch. Try means block containing risky code, and throw means use to signal an exception. Catch is handles the exception. So try catch block syntax. Here we have given one syntax for try catch block. Try within bracket catch exception type. Here you see underscore type E. So this is how the catch handle the exception. Next, try catch example. Here we have given try catch example. Include IO stream using namespace std semicolon. Int main int a equal to 10 and b equal to 0. So this is how the example will look. So sorry, I have to close my video because of the network issue. So try if b equal to 0, then throw. Throw means division by 0 error. See out a mod b, division b. So catch constant care star. Here is star message. Star is pointer, right? And see out message. Return 0. This is how the example of try catch example will look. Here throw statement. Throw statement is used to raise an exception, transfer control to the nearest matching catch. So here example throw 10, throw error. So if there is a 10 is there is an exception. Na? Transfer control to the nearest matching catch, throw, then error. If error is there, then this is string exception. That is throw 10 means integer exception. Multiple Multiple catch block means try, throw, catch, see out, catch again. This is how the multiple catch block syntax will look. Handling exception in C++ program, like best practice. What will be our best practice to handle exception is use specific catch block. Avoid catching all exception blindly. Okay. Use standard exception, that is STD, double colon exception. Ensure resource cleanup, that is RAII. Example, here we have given another example. Include IOStream, include STD except using namespace STD, semicolon, int main, try, throw runtime error occur, catch exception. This is cout e dot what. This is how the example of the exception is. Next, introducing to data structure. The introduction to the data structure, that is unit 9. So first let us know what is data structure. Data structure is the method of organizing and storing data efficiently. Okay, importance. What are the importance of data structure? Efficient data access and modification. So better memory utilization will be there and optimize algorithm performance. Example like arrays, linked lists, stack, queues, trees, and graph. Next, classification of data structure. One, primitive data structure is there and non-primitive data structure is there. In primitive data structure, in, float, char, and pointer, and in primitive data structure, linear array, linked list, stack, queue, non-linear, tree, graph will be there. So abstract data type, which is a abbreviation for ADTS, abstraction data types. And ADT defines what operation can be performed. So it defines what operation can be performed without specifying implementation. So without specifying the implementation, it can operate what operation can be performed. Example, stack ADT. So stack ADT means operation push, pop, and peak. ADT not ADT implementation have 2 weeks. One is array-based implementation, another is link structure implementation. Here, member function in Unit 9, member function is what efficiency is measured in terms of time complexity, space complexity, and common notation is big O. Big O means O1 means constant, On is linear, O log n is logarithmic, and On square is quadratic. So factor affecting efficiency is algorithm design, data structure choice, and memory uses. Okay. In the next slide will be our unit 10 discussing about arrays and linked lists. What is arrays? An arrays is a collection of elements stored in contiguous memory location which can be fixed size for first access using index homogeneous element that can be set of element of same type. Okay, please remember that. And linked list is a dynamic linear data structure composed of individual elements called nodes. Characteristic will be dynamic size, non-contiguous memory allocation, efficient insertion and deletion, sequential access, memory overhead, pointer based implementation. These are the difference between arrays and linked lists. Next, operation on arrays. Insertion, deletion, and searching will be the operation in arrays. In insertion, what happened at n? At n, that is O1, big O notation 1. So at middle, so O n. This is what we have seen here. On means linear, O1 means constant. So at the last, at the end will be constant. So O1 at middle On. Deletion requires shifting. Deletion requires shifting. So in the middle, like same like middle, it will be big O notation N. And searching will be linear search, binary search, and which is also known as sorted array. So linear search again, it's a linear. So O big O notation N, and binary search, it's a graph or it can be logarithmic, so it will be big O notation log n. So for int I equal to 0 semicolon I less than n for AA array. So this is how the array will be look like. Okay. Next, linked list. A linked list is a collection of nodes connected via pointer. Okay. Node structure. Struct node. This is how we structure the linked list. Struct node in data node pointer next. So this is how for the next address is calculated. Types: singly linked list, doubly linked list, and circular linked list. Operation on linked list. Now, since we have seen the operation on arrays, this is operation on linked list, insertion, deletion, searching, and here one more thing we add is traversal in linked list. So insertion, same like the array, beginning O big O notation 1 and O n, because it's linear, so it will move. Now it needs the movement from one source to another. So it was linear, so O n, big O notation n or O1 with the dial tail pointer, with the tail pointer. So deletion requires pointer to pointer for adjustment. No? And searching requires linear. Searching again from one place to one source to another source, it's a linear process. So big O notation. And traversal. Now traversal is note pointer temp equal to head, while temp not null, and see out temp data and temp next. So this is how the traversal will look like. So array versus link. This let's look a quick table comparison. Features will be memory in terms of memory, size, access, insertion, deletion. So array is contiguous, linked list is non-contiguous. Size of array is fixed, linked list is dynamic. Access is fast in array O1, and it is slow, so it's linear, it's slow to ON. Insertion costly, linked list is efficient, and deletion is costly again, and linked list is efficient. Performance comparison between array and linked list, better for random access in arrays, poor for frequent insertion deletion. Linked list best for dynamic memory allocation operation, or for indexing. So here no indexing is there. So when to use what? मतलब whether we should use array or linked list at what time. So use array when size is fixed, fast access needed. Okay. Use linked list when frequent insertion deletion is happening and memory flexibility is required. So these are the example of linked list, singly linked list. Here you see this is singly linked list example. Continue. And this is arrays example. This is how output will be 10 doubly linked list. So see the comparison between singly, doubly and circular linked list example at your home, and we'll be concluding with the self-assessment question. What are the two main types? Please go through it your SLM, and this is our self-assessment question for you to practice at home. And thank you. If any query or doubt, please email at this email ID, and you can check in the website for any details. Thank you. See you in the next class at 12:30. Course code is CSB 1213. Thank you.